Hello everyone, myself Ashwin V.S. Devan, currently pursuing BTech in Artificial Intelligence and Machine Learning in GM University, Davangere. So, why I am doing this video because this is my assignment one of subject Advanced Machine Learning. So, I have choose the topic that is model evaluation, ROC and AUC versus accuracy. So, why I have choose this a model because so many people have been trying training in ML models. So we need to know that what is the ROC and AUC accuracy. That after they training the model, we need to get to know that what is the accuracy of it. So I have choose this model since I am working a lot of projects in the ML models. So I have choose this topic. So now let's go with the coding part or PPT first. And team myself Ashwin V.S. Devang. And introduction. Many real-world problems such as fraud detections have a high risk skewed classification. As we know that so many people are going to fraud in this in the current situations. So we use ML models to segregate those things. We can see in a mail, right? Relying slowly on accuracy in these cases can be misleading as it's biased towards the majority classes. We must use advanced methods to truly access a model ability to identify rare but critical events. Like we need to use a more like model like advanced model. So since we use a normal ML models means sometimes the error will be happen. So we need to train a lot of data sets to get an accurate result. A data set selection and pre-process. First, we need to get the data sets. So later we need to properly segregate and we need to predict, right? So using the credit card fraud detection data set. At present, we have used credit card fraud detections for this data set, which is a classic imbalance to classification problem. So where the everything like balanced and imbalanced data set will be segregated into one particular data. Then we have trained that. Data preparation includes feature scaling and proper train test split data. So as we know that while training the model, we need to divide the data set into two parts. That is a training and testing. So 80% training and 20% testing. So the primary objective is to build a model that effectively detects the rare fraudulent transactions. So what I have building this, the main aim of this project is so to predict the exact fraudulent transactions because so many people are not verified. So we need to predict that as we know that the credit card fraud detections. If I get a credit card, so many people are getting a fraud. So that is what we are going to predict now. Model implementation and accuracy. So the decision tree classifier was implemented and trained on the pre-processed data. As we know that we have used confusion matrix that is a true positive and true negative. The highly accurate high accuracies that is 95 99% may be deceptive as it likely reflects the model ability to classify the majority non-fraud class. So we are going to predict 99% of the accuracy. Just think. So we are not going to predict like a casually. So we are going to predict a manual uh, like a more accuracy one. Evaluation performance, as we know that we need to check like everything, consistency, mitigation, human factors, everything that is going to predict perfectly, right? And a real world benefit includes strategic like 30x faster. Like manually, it is not possible to predict. So 30x faster by using ML model, it is going to predict in a 30x faster. Okay, focusing on the minority classes like recall, precision, FS scores. So after training, so we need to get recall, precision, FS scores. Like based on this, the model will be trained. Okay, and the scores of how to predict that model. My model is truly well missed. By these three factors, we are going to predict that. So recall measures how many actual fraud cases were correctly right. Okay, this is going to predict it by the recall. Precision measures how many of the model positive predictions were actually fraud. Okay, then F1 score. F1 score the harmonic mean of precision and recall. So these are the two factors, recall and precision. After that, it is going to predict the F1 score. The power of ROC and AUC. So the main thing ROC means receiver operating characteristics and AUC means area under the curve. So these are the two major factors as I said. Curve plots the true positive rate, that is a recall, versus the false positive rate across the classification threshold. Okay, then AUC is a single value that summarizes the curve. So means after getting the exact value that is going to predict the whole summary of the model. AUC indicates the model discriminate ability. It is its capability to separate positive and negative classes independent of a specific thresholds. Why ROC and AUC is superior for imbalance? Because so the main focus on this slide is imbalance data set. Sometimes we will get a lot of imbalance data set, but what is the main kind we need to use ROC and AUC? Because accuracy is threshold dependent and highly susceptible to the class imbalance bias. Okay, so since there is a lot of imbalance, we need to use this, so the data will be like a balancing one, so it will remove imbalance data set everything and make it as a balanced one. ROC AUC is a threshold independent and remains a reliable measure of model quality regardless of the class distributions. A high AUC score directly confirms the model true potential to rank fraudulent cases higher than the legitimate ones. Means AUC will be more score, then automatically we can predict that. So my model is totally trained and it's a well balanced data. Okay, let's go with coding part. Okay. Okay, so this is my model I have created. Okay, this is my coding part. Okay, so now I have used a decision tree classifier as I said, and also there is a escape model selection, that is a training, and we are going to divide the data into training and testing. And okay, let's run this code. After running this code, you can see here. See, I have run this. So now it is going to show the accuracy, that is a 99.8%. That is a highly accuracy I have received, and precision, that is 0.50, since it is under fitting, and recall 0.12%, F1 score is 0.20%, and ROC and AUC, that is a 0.84, that means 84% of the ROC AUC curve will be there. And confusion matrix, this is the data set I have trained. And class weighted decision tree, that is accuracy for the class weighted 98%, precision 0.6%, and recall 50%, F1 score 0.10%, ROC is 74%, and confusion metric as it is. Unsoupled decision tree, I have received 98, 0.6, 0.50, 0.10, and ROC same 74%. Then okay, summary of this model performance. The whole summary, that is a baseline and class weighted and unsampled data. These are the three major. You can see concentrate on this ROC and AUC. That is for baseline DT, it is a 0.84%, and class weighted DT, that is a 0.74, and also unsampled data is 0.74. Okay, so for threshold, you can see these are the values of the thresholds. Okay, this is my model, trained model. I have received a best accuracy compared to all other accuracies. Okay, so this is one of the predictions we can conclude that ROC and AUC, by how to predict that my model is best out of everything, means you can add an inbuilt features, that is ROC and AUC. So this is one of the features we can conclude here. Okay, and yeah. So then, why one thing I can say, why we need to check ROC and AUC, because if you train a model, so many times it may be incorrect, and also the model is trained only a particular time, particular data. So that is why we need to add a features, that is ROC and AUC versus accuracy. So then we will get an exact answers and exact result how my model is trained. So that is why we are going to predict and add a features, that is ROC and AUC. So this is my conclusion part, and thank you so much for this assignment. I am very pretty good or to take this opportunity to present, and I want to thank for my guide, that is Akshata ma'am, is a assistant professor in AML department, and this is my assignment one. Thank you so much.